Today we're going to use some polyatomic ions. So a polyatomic ion is a single charged particle that's made up of more than one atom. There are a lot of really common polyatomic ions. Some you've probably even heard of before you got into this class. Carbonate, nitrate. I know there's always a discussion of nitrates in hot dogs. They are used often as a food preservative. Okay, and let's just go from there real quick. So a nitrate is made up of one nitrogen covalently bonded to three oxygens. It has one extra electron, which gives it that -1 charge. So all nitrates are always -1. Okay, so if we pair that with a sodium ion, and we know from the previous video, a sodium is going to be a +1. Okay, so if I make my little chart here, this one's really simple. So when I have my chart, my +1, -1, oh, they equal. I don't have to add anything. Boom, I'm ready to roll. So my formula for sodium nitrate, NaNO3, sodium nitrate. Now, when we start using these polyatomic ions, this is where people get their temptation to do like nitro oxide or something like that. All the names that we do are going to basically be two parts, sodium nitrate, okay? Not three things. It's called binomial nomenclature, two-part names. So your name should have two parts. So if you get this, itch to do sodium nitrogen oxide, remember, two parts, okay? So if we pair that nitrate with a calcium, which is a +2, and nitrate is always a -1, so -1 +2, looky there. So +2, -1, they don't equal. 1 is smaller than 2, so I'm going to add another nitrate. Now we're on the good foot, +2, -2, so I need two nitrates to match up with the +2 calcium, which is what we would expect. So that's going to be CaNO3 parentheses 2 calcium nitrate. Calcium nitrate. CaNO3 2. Now here, notice there's not binitrate or dinitrate or anything like that. We don't use any sort of prefixes with ionic compounds. Okay? Now, aluminum nitrate, same deal. It would just be Al +3, because aluminum has 3 valence, loses 3. And then the nitrate, 1, 2, 3, 1 aluminum, 3 nitrates, because -1, -2, -3 cancels out the +3. And there you go. Okay? So, let's just do one more here. Let's do aluminum carbonate, and you can pause the video, and I'm sure you've already got it memorized, but if you don't, you can check it out. So, aluminum carbonate. So we know that aluminum is a +3, and then hopefully we're learning that carbonate is CO3 -2, so I got a +3 -2. And so when I look at that, +3 -2, it's going to have to go to 6. So how that works is we add a carbonate, that gets me to +3 -4, add an aluminum, that gets me to +6 -4, add another carbonate, CO3 -2, there you go, that gets me plus 6, negative 6, and so I have 2 aluminums and 3 carbonates. And how you do that is Al2 parenthesis CO3 3. That's aluminum carbonate. See, the 2 indicates that 2 of these, the little 3 indicates that I have 3 total carbonates. So each carbonate is a CO3. So in this, I have 3 carbon and 9 oxygen total, but this is the correct way to write it. Don't write it C3O9. That doesn't make any sense. That's not a thing. What we have are 3 separate carbonates.